Great news, everybody. You get an easy day now. After 2 grueling days of integration by parts and tabular integration and circular problems and all this crazy stuff, we get to integration by partial fractions. Integration by partial fractions is an incredibly important integration technique for lots of reasons. One is there's a giant field of problems that are doable by partial fractions. There are all kinds of complicated side methods for partial fractions, none of which are tested on the AP exam and the IB exam. If I have time, I'll make some videos for those in case you want to know about them. For now, it's a basic thing that lets you do some amazing things. Before I get into that, though, I want to go through the very basic skill of combining rational expressions. So, do you know how to subtract those two things? I hope so. You should be getting like a common denominator. So pause the video, revel in the niceness of this easy problem. Simplify that and figure out what it is. So if you were to multiply this one over here by x minus 2 on the top and the bottom, and multiply this one over here by 2x minus 3, plus 3, on the top and the bottom. Let's see here, on the left side I'd end up with 6x plus 9 over the product of those things. I guess that would be, I'll just leave it alone, 2x plus 3 times x minus 2. And then, this other one's going to have the same denominator. This is 4x, was not minus, plus 8. Sorry, it is minus. Sorry, minus 8 over the same thing, 2x plus 3 times x minus 2. So when we push these things together, we're going to end up with 2x, let's see here, plus 17, all over it would be 2x squared minus x minus 6. Okay? So, do we know how to do that? Yay, fantastic. Now let me explain to you the point of integration by parts, of partial fractions. Suppose someone asked you to take this integral. I'm going to assume we would hide and cry. This is crazy. This is terrible, right? But we know that this is the same as this. Instead of doing this ugly integral down here, we could do the integrals of these two individual pieces, right? Each one of those is very easy. It's a really simple little natural log thing, right? There's an x on the bottom, right? So the integration by partial fractions is basically about how to take something like this and decompose it into two smaller fractions. Okay, so that's what this lesson is going to be about. So, as an example, I'm not going to do the integral. I just want us to figure out how to rewrite this rational expression as the sum of two rational expressions. Right? The first step is basically recognizing that denominator down there, that x squared thing, must have come from two separate factors. So let's figure out what they are. Right? The top is definitely 7x minus 8, but the bottom would factor, right? It's going to factor as 2x and x, and then we'll have minus 1 and plus 1. Okay, so great, we know it's supposed to look like that. So now I look at this and say, okay, this means that 7x minus 8 over this thing, 2x minus 1 times x plus 1, we know that it must somehow be equal to something over 2x minus 1 plus something over x plus 1. Because I don't know what those two somethings are, I'm just going to call them capital A and capital B. And this problem is basically going to be about solving for what capital A and capital B are, right? So how am I going to solve for those things? Well, what I'll do is I'll sort of multiply the entire problem through by this denominator, right? When I do that, I'm going to end up with 7x minus 8 equals A times the x plus 1 term plus B times the 2x minus 1 term. That's some fairly basic algebra there. I skipped the step, and I hope everybody's comfortable with that. So the next step is where I'm going to sort of start doing some sneaky stuff. Because you might be looking at this going like, wait a minute, this is kind of wacky. Like, how am I going to solve? There are 3 variables in this problem. I only have one equation. How am I even going to do this? I want to explain what I'm doing here because I want you to understand it. The idea is this statement here must be true for all values of x. Like, we understand there's a specific value of a and a specific value of b, but it has to be true for all values of x. So what I'm going to do is I'm going to choose some convenient values of x. Because it has to be true for every value of x, I'm going to first see what happens when x is -1. Now, how did I choose -1? Well, take a look at this. If I choose x to be -1, this will turn into 0, which will obliterate the a, right? So I'm going to choose x to be -1. When I plug in -1 for all of the x's, I get -7 minus 8 equals 0a, haha, plus b times -2 minus 1, -15 equals -3b. That means b is 5. Okay, fantastic. I figured out what b was. Okay, next I'm going to want to do the same process, but I'll use a different value of x. This time let's use x being, well, what would be really convenient for this one? For that one, it'd be really convenient to use 1/2. If I plug in 1/2 everywhere, I'll end up with 7/2 minus 8 equals a times 1/2 plus 1. So let's see, this thing here is 16/2. So when I subtract that, I get -9/2 equals 3/2 a. So when I multiply both sides by the reciprocal by 2/3, I'll end up with a being -3, right? So now I found my a and my b values. I'm not done with the problem, and I'm going to need to zoom out so I can sort of see my work from before. This right here is what I was working with. I knew that my problem was supposed to be equal to this, right? So now that I found the values of a and b, I can rewrite it. This original expression, the thing I started with, is going to be equal to -3 over 2x minus 1 plus 5 over x plus 1. Now, I know I didn't actually ask you to take the integral here, but if I had started by asking for the integral of this, I wouldn't know how to do it. I would instead simply have done this integral. Really, really not a big deal. Okay? I do have one more example where I'm going to ask you guys to try this on your own, but before we do that, I do, just so as a last bit of review, how do you do this integral? Like let's just focus on that one, right? The idea is we know this is going to be a natural log problem because it has an x on the bottom, but we'd have to use a u substitution. The u would be 2x minus 1, but we can use our shortcut method. Because the derivative of this is simply 2, we can do the integral and just multiply by the reciprocal of that, by 1/2. So what you would have ended up with here is -3/2, the natural log of 2x minus 1 plus c. If you don't see that, I'd really recommend, pause the video, do the full u substitution, and see that you can get that value as the integral. Okay, so now we're going to actually try one of these problems on its own. Before we go on to consider our other example, I thought that I would mention that the best indicator that you should use integration by partial fractions is basically that the denominator of the integrand is factorable, and you know that substitution won't work. So if you're ever looking at sort of like a rational expression, so a large fraction, you're trying to take the integral, and the denominator is factorable, and you don't see any other way through it, partial fractions is a great way to go through it. So with that said, we'll go on to our other example. So here it is. I want us to simplify this integral. So follow the steps we did in the previous one to decompose this into two partial fractions. So sort of start by factoring the denominator. After that, set up the decomposition and sort of check back in with the video to make sure that you've got the two pieces right before you go and try to do the integral. So pause the video and give this one a shot. So first of all, we recognize that this thing factors as 2x minus 1 times x plus 4. And so that means to actually do the partial fraction decomposition, we write our original expression, and you write it's equal to a over one of the things plus b over the other one. Keep in mind, if you decided to do these the other way around, not a big deal. Like if you decided to put the x plus 4 first, and that means a is on top of that one, it's fine. It just means your a and b will be reversed from mine, and that's not a big deal. As long as you follow through, you'll be fine. The next step is that we multiply through by sort of this denominator. When you do that, you're going to end up with 6 minus 3x equals a times sort of the other denominator, x plus 4, plus b times 2x minus 1. And this is the point where we're supposed to choose the two convenient values of x to proceed. So if you haven't already done this on your own, pause the video and work through this next part by yourself. So we should be choosing x equals negative 4 at one point and x equals 1/2 at the other. When I plug in negative 4, I end up with 6 plus 12 equals, well, the a part's going to cancel out. And then the b part, when you plug in negative 4 sort of over here, we're going to end up with negative 9, so minus 9b. That ends up giving me 18 equals negative 9b, so it looks like b is negative 2. So we found one of our values. Now for the other one, we're going to plug in 1/2. Plug in 1/2, I'll get 6 minus 3/2 equals a times 1/2 plus 4 is basically 9/2. So this ends up being, it's actually 9/2 equals 9/2 a. So it seems pretty clear that a is 1. Okay. So now that I have those two values, we can take our original integral, this thing, and rewrite it as this with the a and b swapped in, of course. So let's see here. That means we have, our problem basically changes into the integral of 1 over 2x minus 1 minus 2 over x plus 4. And this is the integral. So now really close to being done. Again, if you haven't done this integral by yourself, pause the video and make sure you remember how to do this. This first one technically would require u substitution, but the derivative of this is 2, so we do the reciprocal of that. We're going to get 1/2 the natural log of 2x minus 1. For the other one, I'm going to get minus 2 natural log of x plus 4 plus c. So this answer is good, but there's a different answer that's going to show up on tests and things. That different answer is, and on the IB exam they'll do it like this, they'll basically say write your answer in the form, the natural log of f of x. In other words, write your answer as a single natural log. Right? So the question is, do you remember how to use properties of logarithms here? Do you remember that you can put these powers up, right, to basically get the natural log of the square root of 2x minus 1? I mean, even there I wrote the square root of 2x minus 1 instead of 2x minus 1 to the 1/2 power. For the other one, we get minus the natural log of x plus 4 squared plus c. And that's getting closer, but to get to a single natural log, we remember what you can do with two natural logs that are subtracted. If they're subtracted, we can do the natural log of the first one over the second one. And in the end, we get this really nice, compact answer for what the integral of the original expression was. So this is integration by partial fractions. It's probably one of the most important methods in this chapter in terms of the actual AP and IB exams. Partial fractions and parts are sort of the two biggest and most important ones. So that's all I'm going to say about this one for now. I'll see you in class.